All right, good morning. I'm planning on doing LeetCode contest 297 from last Saturday. So let me share my screen and we'll do this one virtually. All right. Okay, here we go. All right, open these guys up. Okay, so this one we should just be able to perform the simulation of the adjacent difference times the tax rate. Return the amount of money you have to pay in taxes. So 0 for that first one. Second dollar you earned is taxes 25. Oh, income's 2. Okay, income doesn't go all that way up. Okay. Up to income 10. Okay, and then those are monotonically increasing. Okay. So I should have started this one. So I started at 6:01 a.m. to 6:03 a.m. Okay, so it took about 2 minutes for the game plan. Oops. That's for the game plan. So up to income threshold T, inclusive, right? Or non-inclusive, is it? 10 minus 7. 2 minus 1, yeah, okay. 10. Zero to 3, or it is 1 to 3, 4, 5, 6, 7. Okay, so it is inclusive, right? Okay. 2 minus 1. 5 minus that, okay. Is it inclusive? Hold on. Yeah. Okay, don't overthink it, right? Let's get going. 6:05 a.m. to, let's see, it's about 6:05. Okay, so it's about 4 minutes for the game plan, and then how many are minutes for implementation? Clean up the, it's a little bit, shorten it up with using declarations. Okay, so this is our array of taxes up to a threshold, and then double tax, return the tax at the end. Okay, so for, let's see, we can, there's only 100 of these things for tax brackets. We just use a map. Either that or we do binary search to look at the tax bracket we're in for each item. All right, so let's just use a map. Of one. All right, lookups. int, and then the tax rate can be a double. For auto, it's called a bracket. In the array, it's a tax bracket. Let's see. The first one is an int, which will be it's high and low for each of those. Pair of low will be initially 0, high will be the first item. Okay, so high equals bracket of 0. Well, it goes last high, current high, equals bracket sub 0, and then the rate equals double rate equals bracket 1 divided by 100.0. So each index I from low to high, and it is not inclusive, so one is less than high. Angry. Some more coffee. Okay, so low to high, we're going to fill in the map. So for this dollar, it's going to cost us that rate. Okay, and then we can just go through for auto T, or just go to I again and whatever. I from 0 to threshold, not inclusive, tax plus equals M sub I for each rate. Add them up. Okay, let's see what happens here. 2.65. Okay, looks good. And the other test cases, submit it, and let's get going. Okay, good enough. Since I'm doing this virtually, I might as well just solve in all the other languages here real quick, right? This is a pretty decent solution, nothing too fancy, right? Just go through each bracket of the input array A. Well, I might as well write it down while I go right here. Let's do this. A few solutions. Iterate through all possible text brackets. Right, so you can either use a map or use binary search per lookup. It doesn't really matter. Binary search would have the less overhead of memory in favor memory over runtime. Maybe we'll just do that later. Whatever. But anyhow, iterate through all possible text brackets of the input array A and place each text dollar value into a map. Then accumulate the total tax from dollar equals 0 to t non-inclusive. JavaScript Python 3 C++ do some Rust too. Rust. Stick that one there. Okay, Python 3. Right, so same game plan. Use a map and to store dollar tax values from 0 to t non-inclusive. And we can accumulate that sum. Yeah, let's accumulate that sum functionally here real quick. Let's just do that. It'll be a little bit cleaner, right? So return accumulate. Yes, that should be fine. All right, m dot begin, m dot end. And then we want to do this. Let's do immutable lambda. Care about that thing. Capture m itself by reference within the lambda. And just return m sub I. And we accumulate that thing on 0. Uh-oh. Oh yeah, I need to have a running total. T plus that guy. Uh-oh, that is not right. Oh, plus I. Oh, that's good. Okay, that should work. No, oh man. Okay, what's going on? All the mapped rates. Really? That doesn't work? T plus, oh, it should be 0.0. You want to double? Yeah, oh wait, no, that's not right. Oh, it's less than T, right? So, okay, so m dot begin plus T. 0 to T non-inclusive. Uh-oh. T m dot begin. What? Oh yeah, the map can't do a plus like that. Okay, so I'd have to stick it into pairs. Now let's use this. Using pair goes pair and double. And pairs equals vector pair. Okay, now I'm just kind of wasting time. All right, let's get going here. We can copy the map into those pairs, and then we can use the vector. We add on the T onto the iterator, which is a huge pain, right? It's fine. P dot begin, P dot end. That should be fine, I think. Okay, that does look good. Okay, so C++ is functionally verbose, and I could see some advantages of doing that, but it is kind of convoluted. This original answer looks a little bit better. And yeah, let's do this in the other languages here real quick and get going. I don't want to waste too much time. I'd like to get to question 4 if I have a chance. It's that one I usually miss. Okay, so the implementation implementation in Python 3. Let's get going here. All right. M is our map. It'll be a default dictionary. And it will store floats. So for each interval, between low and high, and low, high. Be destructure this thing as the index. Did I call this thing in C++? Rate. Okay. Each ith rate in the input rate A. Low is high, high is I. And then for J in range, low to high non-inclusive. Suppose we could just keep track of last as well. Maybe I'll clean that up here in a sec. Let's just go with this for now. M sub J equals rate divided by 100. That'll be a floating point number. And then we'll return M sub I will be the sum of M sub I for I in range T non-inclusive. There we go. So Python 3 is way easier than C++, right? That's cool. Super short and concise. And let's try just using last. So we're 0. Okay, so then last equals I at the end here. And then for J in range I until last non-inclusive. Okay. No, hold on. Ith rate, I till last. Oh, well, let's do previous and current. How about, or let's just do low and high. It's fine, right? Whatever, it doesn't matter. So from low to high. So I had this backwards, right? And low goes high. That looks good. So let's just do last and whatever. Each ith rate, we go from last to I, and then last equals I. That looks a lot better to me. It looks a lot cleaner, right? Instead of having two variables, just have one. And let's clean up the C++ solution, do the same real quick, and then move on. And it doesn't have to be perfect, right? But I can clean it up a little bit. This version, clean it up. Do last is 0. And then ith bracket. I is that guy. Last is I. I'm gonna go from last to I. How about this? Well, last less than I. Whatever. Let's just use I and J. Let's just do it this way. J is this guy, rate is this guy. That is fine. Well, I is less than J. M sub I plus plus equals the rate. I will equal J at the end. That looks cool. Yeah, it looks good. So I kind of like IJ a little bit more than high and low. It's cool. And then I think it's a little bit better than last as well. So let's just do it this way too. Okay, I equals 0. And this is the next jth rate. While I is less than J. And so I equals that guy. Equals 1. Okay, looks good. Looks good. That's cool. All right. Let's move on. Okay. JavaScript 623. Let's get going. This is taking like way too long. All right. Array, our threshold. I had 0 initially, then we'll put our map. Okay, and for jth bracket, the text rate of the input array A. All right, so tax equal rate divided by 100. That'll be our floating point precision number. And then while I is less than J, m dot set I plus plus equal to that tax. All right, and then return array keys, array of size t for 0 to t non-inclusive, map each ith index to m dot get I, and then accumulate the sum using low dash. Okay, that looks good. Looks good. Looks good. Okay, Kotlin, array or threshold for income, coffee, quick, tax equals our tax in the end. Oh, actually, I'm just going to accumulate the tax in the end, right? I don't need a separate variable. So that's I do need my map. It's a mutable map of integers to doubles, and for jth rate of the input array A. Tax is equal to the rate divided by 100.0, and then while I is less than J, m sub I equals rate I plus plus, return int array size t 0 to t non-inclusive dot map m sub it dot sum. Range. What is this? Cannot infer type v. What? Mutable map. Right dot two double. Set more explicit, but what's going on? Cannot infer type parameter v. What? What are you talking about? Oh, it should be tax. Oops. Okay, that is right. Right, it's an integer, it's not a double. You're right, Kotlin. Okay. Yay. Okie dokie. And then I'll do rest. Save the best for last. Where's rest? Here we go. Okay. There's our array. There's our threshold. Back 32. BBI. Back BBI. All right. Shorten this up a little bit. Okay. Let readable text equal 0, return the text in the end. So I have 64. Just do that for now. It's okay. Or it's not text. It's, oh, we'll functionally do that, right? So let mutable index I equals 0. Let mutable map equals a hash map. Hash map. See collections hash map. All right, and then for I'm going to call it a bracket in the input array A. Destructure the bracket into the jth tax rate. Brackets 2, brackets 1. Then while I is less than j, m dot insert I, and the jth rate to be let rate, oops, tax goes rate divided by 100. Rate as F64. There's our text, and then we'll return zero until t non-inclusive dot iterate through those. Dot map each item to m dot get I unwrap dot some. Does that work? I don't know. Let's see. No, oops. Okay, it's that thing. No method name invert the range. I wonder if this works like that, and then semicolon there. I have to borrow that thing. Oh, time limit exceeded. Oh, oops, that's right. Increment I already. Let's see. Big money, no whammies. Yay. Okay, cool. So there's Q1. Took a while, a lot longer than I was hoping. But there you go. All right, there's a few solutions. Post that and get going. Okay, how much time do we have left? We have 1 hour left. Okay, so 1 hour remaining. The contest. And method cost and grid. Cost of path and grid is the sum of all the values cells visited plus the sum of cost of all moves made. Return the minimum cost path. M and M are pretty small. Grid is 534,021. Move cost. The path minimum possible cost is 501. Some of the values there's 6. Moving 5 to 0 is 3. It looks like this is a basic dynamic programming type question, right? So it seems like offhand. Move cost for this one. Hold on, 9 and 8. Where's 18 coming in from? Oh, move cost, hold on, move cost. For 0. 9 this way, 8 that way. For 1. Where's 1 and 5? Hold on, I gotta read this a little bit better. Or you can move from one row to the next, fine. IHA's cost of moving from zero, 1, 2, 3, 4, 5. These are the different columns to the next row. 0, 1, 2, 3. Okay. So 1, 5 doesn't exist because it's down here. And then similarly, 10, 12 doesn't exist because it's down here. Right, okay, that makes sense. Okay, so ith move costs to all the possible next jth columns, the next ith row. All right, it's a little tricky, but whatever. When did I start? I don't know, I think I started like 6:30 minutes for a game plan. And the game plan is basically, well, I have to consider all possibilities, right? And then optimally choose the best. And we can do this recursively and then memorize it, right? And turn it upside down. So that's the game plan, right? But use the arch of DP and see what happens. All right. See if I know what I'm talking about. We'll see. All right. Clean up the signature here real quick. Okay. And move cost in our original input array, right? Grid. I'll just call it cost, whatever. Cost is a little bit better. Okay, and M and N is, well, we'll have it, that size and this be sub-zero size. And then we'll recursively go through, actually, let's go with the game plan, right? So top-down solution first will be from I equals 0 until n minus 1 inclusive, right? Non-inclusive. N minus 1 is the last row, which is the base case for which we return 0. That's where the recursive stack will begin to unwind, and then we make the optimal choices. The mu cost, right, for each jth move cost. Consider each ij and then return the minimum of that, the minimum of them as the best, right? Best initially is infinity, and then each candidate jth move cost will choose the best of them and return it, right? Okay, that's the game plan. 6:39. About 9 minutes for the game plan, and then from 6:39 a.m. to whatever it is for the implementation. Top down, which that should work actually. I don't really need a memo, I don't think. Since n is small, I think even without memoization, it will not TLE. So let's just see what happens. Function. Right, this will return the optimal choices, the recursive stack unwinds, and each ith stage. Capture go within its own recursive lambda, and then if I is equal to m minus 1, return 0 at that case. That's our base case. Return go. Let's turn that 0. Okay, so for j, each jth choice to 0 to n non-inclusive, our candidate will be the ith value plus the move cost. Okay, we want to best, right? Okay, best, oops. That equals 9+7, and best is infinity. Return the best at the end. Best candidate. A sub I sub j plus the cost of moving to j. Oh, the cost isn't occurred. Oh, hold on. Yeah, I have to keep the cost as I go. Hold on. Except move costs. I just 0. The move cost is initially not incurred. Okay, so if I exceed 0, then we'll have the move cost. Cost. I'm moving from, I'm moving 2. If I move 2, 0, that'll cost from 5. From 5 to there. So it's from there. Cost of moving from a sub ij to the jth column. Otherwise, for the very first one, if I is 0, we don't have this move cost. Okay, and then best equals the minimum of itself in that candidate. Let's see what happens. 3 is not right. Uh-oh. That is way off, actually. What happened? I can start at any of them, right? Best in the end. It's starting at any of them, right? Starting at I. Oh, IJ. It's a chief. Start at any I chief column. Wait, hold on. Start any chief column. Yeah, yeah, that's fine. All right, so hold on. That's not what I want to do. What I need. That's the I through. We can choose any jth column to start with on I through, right? Okay. So, oh, I didn't even do recursion. What the heck? Oops. Okay, we go to the next. Right, we go to this guy. Okay. The cost of where we're at, plus the cost of moving if we're past. Oh, we need to keep track of where we move to, right? Okay, so I do need I and J, right? Okay. So we're moved to J. Because we're from there. Custom moving from the previous. Right, this will be the last row that we're at, or the last J that we're at. Current ith row, but the last J. Hold on, I'm getting a little bit confused here. You can start in any jth column of the first ith row. And we need to keep track of the last value that we're at. Or say, okay, we move from this last value. Right, so that does make sense to have last. Last will be initially some sentinel value. Just using infinity as our sentinel value is fine. Last index, whatever. Yeah, need a one because last is an index, right? Okay, so any of the current jth columns of the ith row. Okay, so the first time we don't have to incur the cost of last, the move from last. The move from last to this J. It's the last I, current J column. What's this cost? The cost of moving from the last yeah, last needs to be a value. Okay, so it's last, as it doesn't equal infinity. Last will be the value itself. So we can look it up here. The truth column, okay, otherwise initially last doesn't cost anything. Let's go to the next row. Given last as the current a sub I row, so jth column value is last. Okay, I think that makes sense. Let's see what happens here. 3. Holy cow. Okay, I'm way off. What is going on? How's it returning 3? 0 to m minus 1, non-inclusive. The minimum, the best candidate. I plus 1. Last value. I don't know. Okay, hold on. Let's see. 6:39 to 6:49 a.m. About 10 minutes for implementation of top down, which results the wrong answer. Okay, 6:49. Into whatever. I need to debug this thing to see what's going on here. Like, this is not right. Expect 17. Go. Best and our candidate. Oh. There we go. Okay, so that makes sense. Last is 5. That went from 5 to the current row. 4. The current row 2, right? Just stay where we're at. 5 plus 4 plus 2 is 11 plus the move cost. Move costs from 5 to 4. Should be 14, right? 0, 1, 2, 3, 4, 5. Move cost. That should be 14, right? 14 plus 2. So I'm not doing the move cost right. Oh, if it's the last one, we do have to have that last move cost. I do need to add that. Okay, so what is the last move cost? It is so the last to last move cost. Okay, so do you want to take that into account? Take into account the very last move cost. Try and zero for the last row. Do you need that last move cost? Still not adding the separate those. 5 is 4 plus 2. And I'm not. Last was 0. Next. Hold on. Yeah, I think this is still off. Right. Just something's missing here. It's not quite right. 11's too good. So the initial path is 5, 4, 2. That's what I want to work on, right? 5 is 4 plus 2 is 11 plus 14 plus 2, right? For the move cost. Which is 5, 0, 1, 2, 3, 4, 5, sub 0, 0, 1, 2, 3, 4, sub 0. Chief value of the last cost. Chief value of the last cost, right? This should be chief value of the last cost. One piece of IJ. You don't incur another move cost after that last move. This plus that. Hmm. Zero, 1, 2, 3. Base case, it bottoms out at 3. As the recursive stack unwinds, last is 2. Cost is just 2. Looks right. Last is 1, 3. Last is 1. What? Ah, come on. What the heck? Keyboard and trackpad just decided to no longer work. Come on, come on. Okay. What am I missing here? Last value by j. 0. The best jth column from the last ith row. It's the last value. This one. I don't know why this is taking me so long to debug. It doesn't seem like this is truly too complex, but I'm having a hard time. 2 is fine. The base case is 2. That's expected. Okay, so the base case being 2 is the recursive stack bottoms out here. 2, oh no, it's 2 plus the path to 2. It should be 2 plus 2. So I'm not counting that. 2 plus 2. Oh, a sub, I'm not counting the value a sub I sub j itself, right? Okay, maybe that's what I was missing. Okay, that looks good. All right, missed that part. Okay, let's do the other one real quick and then. Come on, big money, no whammies, 6 and 17. Okay, that was good. All right. Okay, so I was missing that part. Sometimes fast is slow and slow is fast as people. Let's see if it TLAs or not. If it does, we'll add the memoization. Is cool, right? Okay, it does TLE. All right, we'll add a memo and then we'll turn it upside down. All right, okay, so 7 a.m. TLE, hold on. How long did it take me to debug this? Okay, 7. Okay, 11 minutes for debugging. Oops, I was missing a few things. And this results, so this results in the, I believe the correct answer, correct solution, which results in a TLA due to lack of memoization. All right, let's add the memo. 7 plus memo. Using map, so onward map. The state is going to be checked by a string. Okay, map m equals this guy. And then let's do this. Key will be our last state. So last string. Last, K is our key for the last state. We want to only compute it once. So if our map does not have the key, compute that subproblem solution once and store it for future lookups. All right, this one should be accepted. All right. 17.6, and this third one should not TLE. It should have some answer. Okay, 214. Oh, 2 still TLE. Okay, so we have to turn this thing upside down. The OJ, the online judge, is very particular about C++, which also results in TLE. This one didn't give me a Must be a hidden test case, I suppose. I don't know. Okay, so anyhow, let's just do this bottom up. Same thing, just mimic the recursive stack unwinding. And explicitly set our base cases first. So DP about two-dimensional matrix. And the base cases will stick at the end here at the nth row inclusive. And each of those will have 0 to n minus 1 for jth columns. Okay, our base cases are set by default here as 0. So that's good. And then we'll return DP sub 0. How am I going to check this state for last though? Oh, excuse me. We'll explicitly iterate through all the last values from 0 to n. Explicitly set last in, then okay. N is not a valid last. Right, so then Fendi, do that. Okay, then for no I from -1 down to 0, we'll mimic the recursive stack unwinding. J, it doesn't matter which way we go. I does, since we want to build upon the previous ith subproblem solutions, the base case M. Okay, so then best. Okay, so I do want to explicitly, let's do this. Bring that back. 9, 7 for infinity values should be our default. Build upon. So we do need to explicitly state the base cases for the mth row for all jth columns of the nth row. M sub DP jth column of the nth row set to 0. So those are explicit base cases of row M, all j columns of that row M, and then we'll build upon that. And so the candidate is last does not go in. Cost of last j was 0 plus a sub I sub j plus dp state of I plus 1. So the last value of the a sub I sub j. So dp sub I sub j equals the minimum of itself and this candidate value. Okay, let's see what happens here. Whoa, last is not. Ooh, oh yeah, I do need to go through last, right? For each last value that we came from. All right, so for last is 0. Last is less than equal to n inclusive. Then consider all these, okay. Something like that. Whoa. Last is not n. plus 1, let's say some ij. So ij is m plus 1 must not equal n cost last check dp supply check. GPU start in what? Really? What is wrong here? 0 to m inclusive, 0 to n inclusives. That's fine. That part's all fine, right? Yeah, that's fine. That's not going out of bounds. But what part's going out of bounds then? Just set to infinity for now. That part looks okay too, right? That's okay. So then what's wrong with this part? Y plus 1. Cost. Oh, wait, hold on. Cost of. Okay, yeah, last might not be. Hold on, last. Last should be up to. It is cost, isn't it? Hold on, last. Zero to M. Should be 0 to M, right? M times N minus 1. Cost of last. Just cost. Let's do this. This part's okay, right? No, this part's not okay. Okay, so ace aj, dp is this guy. Is ij not big enough? What? What's going on here? Last does only, I don't know, cost. N+1 rows, N+1 columns. I'm totally confusing myself. Take a little bit of break. Holy cow. This is a hard Q too. Grab some coffee here real quick. Had a hard time, I'll teach you. Okay. Basically, I just want to have my DP state and explicitly set the recursive Zachariah, right? I'm having a hard time here. And so the last value is, what is the amount of 2, 3, N is not big enough, right? N is the amount of columns for J, but it's not big enough to store last, right? So we need M rows, but then I think it's not big enough. All right, so it's M times N minus 1 or M times N. It should be 6, right? M times N, okay. M times N. M times N for this thing. So explicitly set the base cases. J is less than or equal to M times N. Send those base cases for the DP matrix J. Right, this could be considered K instead of J, whereas J is the Jth row of these things, right? Okay, so it wasn't big enough. And I believe that's fine now, right? No, oh man, still not good. DP so IJ. Oh, current J should J be going M times n 0, 1, 2, 3, 4, 5. Okay, so it's m times n times n for j, but let me just make sure this part's okay, right? J is less than or equal to m times n, oops, plus 1. Right, that part's okay. All right, so let's set my base cases. And after I explicitly set my base cases, which is less than build upon that for each value. So there's two different things that are conflicting here. This one is the last, and then these are all the jth columns for cost. So this guy needs to be explicitly set to k. All right, so let's do this. IJ k. J is this way, and k is last. This guy. That's last this guy, that's current that guy. Okay. This guy will be, there's K. Values m times n. K. This is last. Jth costs from last. The current. So what do I want DP state to be, right? So hold on, I think I'm making this way too complicated on myself. I'm gonna keep it simple, keep it super simple. Keep it super simple. Last is from 0 to m times n, inclusive, not inclusive. What am I doing? Hold on, let's just call this thing last. Just keep things super simple, right? Last from 0. Last is less than m times n. And set to 0. It doesn't cost anything. The nth row. Okay, so closing last. Cost last truth column plus that guy, TP sub I. Current. So current ith is built on ith plus one. This all previous rows to all current rows for all last. All the last ones, all the current ones, right? Yes. Cost of previous. A process to go into current from previous. Current. 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 Jeez. Holy cow, is that right? Switch previous current. Plus the current. Jeez. I don't know. I'm having a hard time here. No. Oh, a little bit off, right? We're a little bit off. Okay. Man, really? Yeah, so still learning DP, obviously. Really struggling here. And the contest almost over. Yeah, the obstacle is the way. I have a lot of room for improvement here, so I'll probably upsolve this one if I don't get it in 4 minutes. Let me see, I want to explicitly mimic the recursive stack unwinding and optimally choosing the best from the bottom up. That's what I'm trying to do, but I'm really struggling. this one's tricky in that there's a handful of things to keep track of. I think I can do this for sure, right? I think I'm on the right path. Top down, top down, hubs memo, and then bottom up is what I'm expecting to be accepted. I is M, regardless of what is last, returns 0. And I is M, regardless of what lasts, explicitly set the base cases here. That should be fine. Base case part's fine. No cross stack of lines from n-1 down to 0. Cross stack of lines. They're pretty shady. Shade possibility. This would be the shade cost. Just the size of the columns. These are all possibilities from the previous. Oh, wait, hold on. Oh, yeah, okay, that's right. I plus 1 is what we're building on from right to left. Okay. Hold on. So the previous a sub I plus 1 sub j. No, we need a j and a k, right? Right, from jth column to the kth column. Right, so if we say j was our previous column and k is our current column or something like that, right? Previous and current. Candidate is a sub I sub j. So j is k is current. Have a current to from the previous plus the previous is I plus 1 a sub I sub j. dp sub current goes the minimum of itself. There's the candidate. Current, this guy is previous. That guy plus the cost from last guy. Last we're seeing is a sub I sub j. To the current cost of last current. So a sub ij is last. K is the current column. It's not right though, because is that right? This is tricky. I'm confusing myself. Just throwing stuff on the wall, see what sticks. I think I'm close though. Quite right though. 0 to n. Okay, so I think I need to go slow in order to go faster. And basically what I'll do next is print out the values explicitly in the memo. And contest is over, I got one. Not one of my best contests, but there's a lot of room for improvement. All right, I'll come back to this. So to do, I'm just throwing stuff up on the wall to see what sticks at this point. So that makes sense to take an extended break, then go slow. Right, remember KISS, keep it super simple. That is, we want to just print the key value pair for each memoized answer from the top down with memo solution to clearly, clearly see how the recursive stack unwinds, right? And thus dictates the bottom up recurrence relation, as well as how those are, right? Fix it as, it's how those are iteratively and optimally built on. Okay, catch you next time.